said, it's being improved. Oh, yeah, it already has some improvements. So it has, I think, there's nothing in there. And there we have our images, so everything happens there too. Security has our default security group. Let's see if that's our group. No. Yeah, no. That's the thing of multi-tenancy. Probably a different tenant. There you go. That looks much more. Forgot about it. Yeah, there is the machines. As I said, there's something we could switch between bot. I think that's the bot checks. They show us we name things too, like everything. Used to be tenant, it's bot check. Okay, cool. Then we can find our security group. We can manage routes. This is all. There we probably see our route right at the bottom. And this is HA. And they did a really nice job. I remember with the network. They see our two computers. One is a char computer, and then is a router, and then it routes to the public, whatever the public goes to. So yeah. As I said, you can have our two net private mostly, and then you get started off with a router. You can do stuff there. You can invent new interfaces, switch them up, down, put routes on it, whatever you want. And of course, as I said, there's also the identity thing, and I said there's different projects. And there are two projects here, demo and invisible to admin. And earlier we were invisible to admin, so we didn't see our stuff because it was made in demo. And you can click on that, and that works out or whatever it does. So that's that graphical thing. So if your data center buys it, it would look like that. Or installed or whatever. So let's get this second thing. Demo time. Yeah, I wrote it down. Password. Got my nose. And there's an admin part where I can go in and then see how much resources each user is. Okay. Now, what happened? That was last week. Google joined the OpenStack Foundation as a rich, so they're a pretty important sponsor now. So that happened last week. Why would they do that? Well, when we remember there's this other company, Docker, which people think is getting too powerful, let's say it that way. And Google's been containers for a long, long time. And they gave the world Kubernetes, which is a way to kind of orchestrate containers. And they want to see the adoption of Kubernetes kind of skyrockets, for whatever reason. So they formed the OpenStack thing to kind of, because they have computers, they have orchestration, so it seems to be a good fit. And so beyond that, there was a keynote in Vancouver. So the last OpenStack conference was in May in Vancouver, Canada. And we had Adrian Otto on stage. He works for Rackspace, and he lives in LA. So lots of people loaded because NASA, JPL is in. He goes. So yeah, he was on stage and showing a project called Magnum, which allows you to put Docker containers on top of OpenStack, and then the Google guy came up, and they were running then their Kubernetes script simultaneously, one's on the Google cloud and one's on the Rackspace cloud. This addition, and it all worked great. So put a link there, but we shouldn't look at it. But anyway, so that's a big change in the world of OpenStack. Because a lot of people thought Google could do their own thing. No, they're there too. So really excited for us. And that's so the people looking for jobs. That's one of the important buzzwords in those days. And this is from what we a hybrid cloud. So hybrid means you can outburst stuff to their stuff. And few enterprises can move it to the public cloud. For most public governments will be the norm, and OpenStack's emerging as a standard for on-premise components of these deployments. And of course, it's the container-oriented computing. Guys have an idea why people go container-oriented computing? That's all. It's all to do with microservices. So it used to be, when days when I did a lot of Java, you put everything in your web app. And it was this big monolithic thing which could do everything, billing, whatever. And then you had maybe 2 tiers, 3 tiers if you're very advantageous of apps. But that, but then you have the problem that you had to scale it for all those big monolithic things. When you did a deploy, you had to start like at 2 o'clock in the night to get everything done. And that doesn't really fit in the modern world anymore. So people say that's not good, let's go and do tiny services, which do one thing. They're just tiny, just a few lines of code, and then you end up with, so I said before we had like 3 tiers, now you have 100. So it has other challenges. And one of those challenges is that you have to kind of run 100 different tiers and you have to orchestrate them. And they're all very tiny, so they're a good fit for containers, which are a good fit for tiny applications. Because you still have those 64 core servers to put stuff on it, and it would be kind of a waste to just put a tiny app on it. So they put containers on it, they can run like, I don't know, 2,000 of those on it. And then you have to manage them, and this is where Google comes in with its Kubernetes. And so that's what they're seeing. And that's why we need that, because the microservice architecture moving towards. And yeah, they did it stuff, Internet scale, whatever. Kubernetes is another hotness in the area. One more thing they said, which is in that, no, the OpenStack guy said it, which is in that quote. The one thing OpenStack allows you now is you can have your old-fashioned stuff running on VMs alongside the new-fashioned stuff running on containers. It's the same cloud. So the OpenStack people are very excited about that. And they needed some container kind of story. When you look at the cloud kind of movement and strategies, Docker was getting really very popular, and people are wondering where would OpenStack fit in this modern world, and so now they have a good story. It's good for them, good for me to work there too. Yeah. But the other story they have, so it's the Cloud Foundry story. So I said earlier, OpenStack is more at home in the infrastructure as a service world. And that's not really where people want how you do modern applications. So people have coined the word cloud native. Anybody heard about cloud native? Cloud native is a word nowadays it always gets a bad rap. So. Anyway, it means that you write applications first and foremost for the cloud, which means you're using the platform as a service type thing. So instead of setting up your own database on some VM, you use whatever is being provided to you, given to you by the kind of operators of your cloud, and all those things. And so your code comes more of kind of connecting those things and connecting all those building blocks. There's also cool tools where they can scale it like to 4 whatever things, and it spins up 4 instances and figures out the database and all these dependencies and spins up more stuff. So there's pretty cool tooling. And one of those things people get got behind is called Foundry. That's something which came out of Pivotal. I don't know, guys know Pivotal? It's a company out in San Francisco. Very interesting thing. It's joint owned by General Electric and VMware. and basically they did this cloud native thing. They invented Cloud Foundry. They then went ahead and open source. It's mostly a Java thing, so it's good for us. Java thing. It's basically an open source cloud computing platform as a service. So that's for the cloud native thing. And many vendors, they put cloud Foundry on top of OpenStack. Pivotal itself, HP, something called Hibernate Dev Platform, which does stuff on top of it. We put .NET in it. Most of our computers run Windows. So yeah, and IBM has some play there too. And everybody has. So yeah, this is what people seem to be buying. As I said, the other thing they're going with OpenStack, putting that platform as a service. OpenStack itself is kind of not very strong in the platform as a service, so they're putting this Cloud Foundry on top. And Cloud Foundry itself, this is what it is. And this is where basically the other stuff comes in. I talked about like Drove, the OpenStack database, because now they have some database in Cloud Foundry, but it doesn't scale very well, doesn't know much about OpenStack, so it can then kind of replace their database with the OpenStack database, their queue with the OpenStack queue, and so on, and then do it piece by piece and make a much more scalable and whatever reliable thing. That's one of the plans here. Very cool stuff. Cloud Foundry. Okay, and the other topic I want to talk about is DevOps. That's something I personally struggle a lot with because it's very, so all kind of explain to you guys. So let's start with what is DevOps? And there's a picture of one of the guys I work for. He's saying he works on a page which I dislike. So that's how he characterized it. All the developers need to carry a page, and that's DevOps for him. When we look at a more formal thing, I'm getting that maybe the developers shouldn't really write an application for it over the hedge to the ops people so they can deal with it, so maybe they should all be friends. So I get that part, but I'm still struggling with that I also need to be friends with quality assurance. So that's another thing. Struggling with, and why do I struggle with that? Well, so we have a team, and we hired a QA guy before we went full board DevOps. And then we said, oh, let's do DevOps. Let's have him be the same manager, everybody's the same. And the first thing guy told me, I don't want to do QA anymore, and I want to develop. And I have everybody in the team says, hey, I don't want to do QA. So I don't really know how that's supposed to work in real life. So this QA thing, I get the ops thing, I'm on board with that, it makes a lot of sense. But the QA thing it's challenging for the ops people and the developers and even the QA people themselves. so that's, but basically what's happening is, so the way we did it, it's probably not as an example. So as I said, we put everybody under the same manager and the same team. Normally, we started out with having Scrum teams where people were together and probably different people, but it still didn't give us a whole DevOps experience. So we more under the same thing. So that's the first thing. And I went to a session inside HP. We sometimes get all together, all for HP and with the DevOps kind of talk about DevOps, and it was very heated because we talked with people actually sell professional services to customers, and they say customers kind of they would like to do so. So their customers, they have like the QA department, they have their ops department somewhere. Usually it's closer to the servers. They are usually in the basement. So the developer somewhere else, and then they say, hey, let's do DevOps. Can you help us do that? And those people meet for the first time. Which, as you can imagine, is not very successful. And that's why I'm saying it's a huge paradigm shift. And that's Campfire, and it's basically what Facebook and Google and those guys are doing. So they don't really have that bigger distinguishing between developers, QA, and ops people. They're all in the same team. Then you have the Scrum thing. Everybody can do the same. So your developer has to write shell scripts. The ops guy writes QA scripts, whatever. You want to have everything automated to begin with, so you don't. So that doesn't mean the thing you might have gotten sucked into in a previous life where you ship the software, so everybody has to follow the test script and report if that button does what it's supposed to. Everything should be automated, so we don't really want to have manual testing in there. So this is a big paradigm shift too. So everything's automated, and that's why it fits the developer. And everybody writes QA automation scripts, everybody writes deploy scripts, everybody writes code. And they're all doing the same stuff. And that's basically how those Facebooks and those people operate. And you know, when you read those stories, they, as I say, you should break things very quickly. Then you need to know that something's broken. So you have to write the monitoring scripts too. So you know that actually got broken. And the other thing is that they have to do deployments on the first day, which is not a big deal. So you have a big deploy script, and you just change a line and it runs through. Whereas when a deploy would mean what ops traditionally did, they SSH in a computer and copy something from somewhere and then mistype and whatever else. At the end of the day, it's horrible. So anyway, everything's automated. That's basically automated. As I said, it's not easy. It's like, I don't know, who's here is agile? I think everybody is agile. Good, because it was another big kind of thing that people had to reorganize. Do we make the project manager the Scrum Master or not? Or should the Scrum Master be a manager or not? Whatever else, and everybody had to find its own way to get there. So the DevOps thing is similar. It's similar to agile transformation. On the trade, so it's not easy, it will be painful, and as I said, the UK guys don't want to do QAs, get them there. Okay, I said that the most important thing is that everything is automated, and you basically have scripts to build an environment. All things are automated. So when somebody says, "Hey, give me a test environment," you can just say, "Okay, no problem." Hit a button, it goes to your OpenStack out. Plugged it now, and it builds up an environment, a stack there for them to test. You tear it down. You always also test then the deployment of everything, because in a lot of traditional deployments, one day you set up all your Ubuntu or whatever servers, and then you kept deploying on top of it, and not noticing, let's say, that the operating system got stale or whatever. Then you decide to update, and it brings in all the 100 new packages, and nothing works anymore. So because you're always fresh, you're always on the heat, and because you can always be fresh, you can use CI. So that's another example of what we do, actually want to do in the future. So what we want to do at HP is, so we develop an OpenStack distro, figure it out, and we want to make sure that it actually works. So we want to build a CI environment where every time we check something in, it goes, provisions a bunch of VMs, stands up, installs the whole distro, then runs whatever tests we have done, make sure everything works, and then it says this is a good check-in. So we not only test the unit test or whatever, we do the whole thing, we install it and run functional tests against it. CI, and that's another part of DevOps, that you can do that all automated. Because it takes ops jobs to set up, how do you start all those VMs, how do you set up the infrastructure, and then the QA thing to run all the QA scripts, and then development, because you have something to test. So there's a lot of emphasis on CI. Automated tests, that's feedback from production. So what I said earlier, when you deploy stuff to production and the Facebook say break fast, break often, you need to know that you're broken. So you need to have also the feedback loop in it. You have to, when you do something, when you do new functionality, figure out how can I actually measure that in a production environment. What monitoring do I need so that I know it's actually working, and then put it in there too, script it too, that it puts whatever. OpenStack uses something called Monasca, so your Monasca agent and whatever, and put a test in for that. So it shows up on your big dashboard. So there's a lot of sort of that stuff. So feedback from production. Okay, this is fairly new. Interestingly, Capital One installed today. They wouldn't expect it at forward thinking, but they are. And they have they made a dashboard where they sort of, that's a nice video too, you time on to look at. But anyway, they made a dashboard where they can track all their systems and the quality, they mean how the tests behave and which is down of the environments and so whatever else, because since it's fairly new, there's not much reasonable tooling out there, as you can imagine. Unless you're Facebook, on the People Tools group, but it's not Facebook, has to rely on the kindness of strangers. Even if it's Capital One, it gets you further. So, that's the thing, that's the use case I want to talk a bit about. So that's it in the past for us. So we got an open source load balancing, so we're working load balancing. And we used to do that, and it was very painful because it didn't work the way it was supposed to. And so we replaced it with something else and working on a new open source solution. Libra is sort of open source, but it's another lesson what we should do one day, talk about how to engage the community. Because it's more than just putting something on GitHub. So that's what they, before I joined the team, they just did that, put it on GitHub, and the community kind of didn't pick it up. So we had to do something differently to get to a more thriving community. So that's a completely different story, how to work with open source programs. So this is basically how that structure, how it works. So we have a client, the recipe is in an OpenStack, and you see it has a lot of services, Libra Advisor, MySQL, Libra Admin, Control, VMN, probably count, probably. So 6-7 services you have to kind of deal with and deploy. So if you do it by hand, it will get tedious. So we use salt. The other thing which is not shown, there's a big Jenkins running somewhere here, which runs all our tests, and also runs production checks. So that's runs production things and stuff. So that's, okay, there are a few people. We had a team lead, we had some devs, we had ops people. They started out thinking, let's have the ops people be on the page all the time. So one got a morning, the other one got a night, and kind of worked out till we got unhappy. And they decided to go more and more DevOps, or we decided to go more DevOps by getting the developers also carrying paging load. And it's basically arbitrary. You can have n number of devs and out of ops. You see that was before we thought about QA a lot. So we made one of the ops guys write all the QA scripts because he liked to write scripts, but as I said, nobody really likes writing QA stuff. So he started hating us and quit. So, okay, then as I said, our deployments were completely automated. So we did that with Salt. They weren't as automated as we hoped. So they didn't have the provisioning of servers in there. So, which then is a problem because they provision servers by hand, and you've seen there were like 7, we're going to do it maybe a little bit redundancy, then it gets a big number, and you have to click a lot of buttons in this UI I showed you, or quite a lot of command line to get there. So that's the one first lesson out of my pain is always automate provisioning of things. Don't do that. Don't leave that to stuff. So when we worked there, when we added a feature, we also had to write the deployment script. Then somebody had to write the automation script, automation test, so the tests can be adjusted. There's a little bit of a school of thought, should use the same dev because he knows the thing best, so he might be able to write the best tests, or should you get somebody else to write the tests? People are often undecided on that. I think the industry thinks it's better to have somebody else write it for knowledge transfer and stuff. But it depends on the laziness of the teams. So usually I have several deployment environments, so I try to go to QA stage and then go straight to production. QA run the tests, and then go to stage run the tests. button, it all happens. We sort of, after a while, we noticed that things go wrong when we let somebody do it all by himself. So we then let two people do deploys. So one can watch the other, make sure they don't do silly typos. So it's just a thing out from the trenches. Okay, then the other thing is we have that problems. And pictures, the set we started, the overstring pictures. Our picture would go off and would stabilize. And then we try to figure out what happens. I don't know, I'm familiar with the 5 whys. That's just hard. So the 5 whys, that's something which comes out of lean stuff, what Toyota is doing. And the idea is, then just ask one why, like, let's make a hypothetical example. So why did the disk run full? You say, well, then maybe the log files didn't get rotated. Then you could stop right there and say, hey, let's put log file rotation in and we are done. But since we have to go to 5 whys, we ask them, why did the log files not rotate? And then further down the line, and then discover that somebody forgot to do that or whatever. Then you kind of figure out where to go from there. Maybe you fix the rotation, but also then why did it actually wouldn't go for done? So somebody didn't do it, and why did somebody not do it? Maybe they didn't know. Why didn't he know? Because his manager didn't give them enough time for training. Why did the manager give them enough time for training? Because he's too busy, or bad manager, or good manager, or whatever.
Fire the manager.
Yeah, something like that. And so then you go back and try to do actually each thing. So maybe we should have a brown bag explain people what the log rotation is. Stuff like that. That comes out of the 5 whys. So you want to always try to do it, but I read a book called Lean Startup. He writes a lot of stories where 5 whys go wrong, how it's also very transformational and difficult process for an organization to actually go that far, because at one point people say, no, it's not my fault, and let's blame somebody. They should have bought bigger disks, you know. Didn't I say 100 gigabyte and put 80 in? Anyway, so that's a difficult, but very valuable to learn about that, 5 whys. Okay, then often what we discovered is we learned about problems too late, so we then put in monitoring and alerting. So we would go to our Jenkins and say, hey, let's add another test, which we should run every 5 minutes to check something. So for instance, make a load button to see if it works. And if that doesn't work a few times, then maybe page somebody so we get it fixed before something bad happens. And so, for some stuff, we just had to, there was no metrics, so we had to, for instance, Gearman we were interested in. So we had Gearman was falling over occasionally. It has to do with how many jobs on the Gearman. Maybe we should monitor that. Sadly, there wasn't a way to do that easily, so somebody had to go out and write for weeks a script to grab that and move it where it needs to go. So that's also something you want to do in a DevOps thing. You wouldn't say, okay, I don't write, that's the thing that everybody works together. It's not like you can get the gray guy, the normal environment is the gray, I don't write production scripts. The ops guy says, well, that's not really my job to write scripts. I install stuff and then nobody feels responsible. But here we all got together and then we all kind of somebody wrote it. And then we had those things then, of course, and when we had the script written, we just don't SSH in and install it. We then put in our deployment thing that goes everywhere, and then put in our stuff. So we use the tool called Datadocs, and something on the web very easy. Because web people. So that's DevOps thing, and that's the big problem is really this culture changing that, getting the people doing the QA tests, getting everything automated, getting the Jenkins or whatever tool you want to use to basically drive all those things, and there's a lot of automation which needs to happen. And the big problem is that a lot of people don't do much automation. There's a lot of stuff still done by hand in computer. And that's a big inspired me and I'm interested if I can do it.
You need a speaker.
I need a speaker for something? I thought it goes off out of this cable. No? Okay. I also need internet for that. So probably should. Yeah, let's do questions.
Okay.
Early, yeah. So let's do questions. You guys have questions about something? Otherwise I can.
Real quick one. So you're running OpenStack on some infrastructure. What's the underlying setup for you? I might have missed that. But
We run so we run OpenStack on all kinds of infrastructure. So we I run OpenStack mostly on my own computer in the dev stack, and then we have a small node deployment of a whole OpenStack deployment team. We have a public cloud with like hundreds of nodes OpenStack set up. We have our hosted services and managed data centers all over the world where OpenStack runs. So we usually run it on very big computers because that's kind of what HP produces. And so there's and very different hardware and software on top of that. So we are really not we kind of go in a very specific niche. So I'm doing OpenStack development, so I hardly ever run real OpenStack at scale because I just develop my thing and then I look at that, and then I work with the team which develops the distro, and they just run it until they can install zeros, and then they say they're done. And then there's another team which installs that and finds a lot of holes and installs stuff, and then it reloads and it finds a lot of holes. And yeah, so there's no really one size fits all. It's all optimized for things for real production. There are a lot of components going there. So usually you run about, people do the 20 servers at least. They need networking gear which can help you with this software-defined networking. Not all gear does that. That would be nice, and then it really depends for what you're optimizing your cloud. The storage, you might bring in a storage vendor.
So you're using like HP pod? I mean, like, are you like
We use
blades and then you're putting just
okay, so our stuff works with everybody's products, and we use everybody's products to test things, but predominantly we use HP products because they're cheaper for us, and we have more of that. Say that way, but we have customers who have Cisco switches, and they don't have HP switches. We have customers. We on the OpenStack at a demo where we put Lenovo servers in or whatever. Everything runs, and from a business perspective, we're happy if somebody buys anything from HP, then we go somewhere else. And so we are not saying, hey, you didn't buy the HP server, so you're not getting anything from us. No. Yeah, so that's us. Yeah. The other ones, I don't know how much they force. Everything. Yeah.
Early on, you were mentioning that some organizations are using the OpenStack, I guess, in place of VM or to circumvent the licensing issues?
They're not licensing issues, it's just licensing costs money. So they just don't want to pay VMware that much money.
So, I guess I misunderstood. So I thought OpenStack could run within something like a VM.
I run it in a VM on my Mac because Mac runs Mac OS, and I don't want to have development stuff polluting my Outlook and whatever. But in real life, with a real installation, we put OpenStack on your server. And the problem with VMware is they have a very weird licensing model, which even goes into there's only certain hardware makes sense to work with VMware. So it's not all servers you could imagine building you can give to the market, because VMware licensing makes it unattractive. And so basically people pay a lot of money to VMware. They don't want to do that. And all they want is basically VMs. So they're saying, hey, why can't we use OpenStack and put KVM, which is free on it, and get KVM stack.
Okay,
Yeah.
that's what's on.
That's
You need the hypervisor, right?
Just the hypervisor, yeah. And there's also networking and management functionality VMware would give you theoretically. But yeah, no, you use KVM hypervisor, don't pay them anymore, and you have more money to buy more computers or whatever you want to do.
What is the best practice for building on top of OpenStack and allowing an AWS deployment?
In AWS type of deployment of OpenStack, well, there's a company, HP bought called Eucalyptus. They provide a kind of compatibility layer between OpenStack and AWS. It's, yeah, that's the only thing I know where it's without any work at the customer. You have to buy that. A lot of people, what they do is they don't really want to. They don't really need they don't really need data compatibility on the compute, on the storage, or whatever. They want to just be compatible on the data on the building block layer, like I said with Cloud Foundry. So they use Cloud Foundry on OpenStack, and you can put Cloud Foundry on top of AWS too. So they integrated that at that level. And we have customers who do that. So besides only Eucalyptus, we have a bunch of people say, well, we want to use OpenStack in our data center, we do Cloud Foundry, something on top, and we also want to use, let's say, AWS or Azure or something, and then we install Cloud Foundry there, and that's how we can be compatible. Or whatever else is out there in the past. Only know about Cloud Foundry. Don't want to say it's the only thing you can do. Okay.
Question of storage. OpenStack Swift. How does that compare to say that's Lucid performance-wise?
Performance-wise, so the performance depends on the hardware and vendor you put behind. Say it that way. So if you buy a ginormous storage array from somebody, then it's faster as if you use old disks. So yeah, and as I said, in Swift there are all those vendors. EMC has a driver for it, HP storage, whatever else does storage. They do drivers for it. You can buy whatever storage they sell. So yeah, performance is not a problem. It really depends how much money. It's more a money problem, how much performance you get.
I think you showed a slide before that talks about Docker and OpenStack. I talk a little bit like how exactly is the use case on like how does it OpenStack works with Docker?
It works very well. So they have this Magnum project, and the Magnum project will install Docker on top of a VM or bare metal thing. And then you can use Kubernetes, Google joined the OpenStack, kind of orchestrate your Docker stuff into OpenStack.
Okay, so they have so basically it's OpenStack and Kubernetes, they kind of work together to manage their containers.
Well, Kubernetes is still a little bit outside of.
Is it more scheduling, or is it?
No, the problem is when you do all those things. So Docker itself has huge problems with networking. I don't know if anybody uses Docker. So yeah, you probably know that when you have two Docker machines on different servers, they kind of have jump through hoops to make them connected in a network. And Docker is addressing that with they bought Socket Plane to address that problem. OpenStack has a project, open source project to kind of address the problem as one thing which needs to be addressed to make that work inside OpenStack. Is how do we network that basically Docker container to Docker container reasonably well? That's an unsolved problem. Then how do we report whatever Docker is saying into the OpenStack monitoring? They have Monasca, but Docker's not talking to that, so somebody has to do that integration. How do we integrate Kubernetes? Kubernetes puts it on Docker, so you have to pre-provision a Docker thing, but how do you go and dynamically provision your Docker hosts? So that sounds a capability they haven't figured out. So Google just joined last week, so there's still so it would be miraculous if they would have figured it all out in 1 week. But yeah, there's still a lot of work to make it all work very well. But the good news for OpenStack is that it doesn't work for other people very well neither. So it's just Docker doesn't have networking. Docker's orchestration, monitoring stuff is still it's all work in progress there. So they're also still very new. And the other thing is, so the other thing probably know this, there's now an open container foundation. So Docker donated a lot of their container code to the open source community and founded the Open Container Foundation. HP is a founding member because we have a huge interest in that stuff. And yeah, so there's lots of stuff coming, lots of exciting stuff coming. Let's think about our perspective. Maybe we can make hardware which works very well with containers, better than everybody else, stuff like that. So there's exciting stuff here. So yeah, it's still early. So Docker is it's still early in probably the hype curve got pretty high right now. Probably the way to go, but there's still a lot of stuff has been solved in Docker. But as I said, you can use this magnet thing and then you can make it work. And people do that, and it's high on the list of it's high on the list of Rackspace probably. Yeah. I said Adrian orders from Rackspace, so they have something where they do a lot of container stuff nowadays. You want to do a lot of container stuff, so everybody's very excited about that. And got Foundry, which is important. Which is the important pass thing as you can deploy the containers. They have that capability. So the big Docker thing, very exciting containers. Yeah, it's another big hype word, yeah.
Getting back to the example that you gave us, Libra,
Yeah.
the team. If I remember correctly, you said 1 lead, 4 devs, 2.
Yeah, it's arbitrary.
No, but it's arbitrary, but you have like a good chunk of ops people on the team, but it's not kind of obvious what the ops people's responsibility is.
Well, so on the DevOps, world, it's everybody's responsibility, everything that does. So it's like in the Scrum, the full stack engineer who does everything. It's the same there. We started out historically having ops people and made them responsible for running the stuff and gave them the pagers. Only they had the pagers, and that frustrated them because only 2 and they had 24 hours. And so then we moved to DevOps, and then you can't just say, hey, you guys. Anyway, so we then just hired more dev people and kind of put that together. And as I said, one of the ops people actually did a lot of QA work, so he was more automation CI engineer. So ops is also the term ops covers a lot of skills which are different. So one ops person might just know how to stage the machine, so the other ops person can install, maintain Jenkins, write scripts for it, write QA scripts and whatever else. So yeah.
It's kind of what you're really saying is like they started off, this was dev, these were ops.
Well, that's
engineers and
yeah, and then the big boss comes and says we do DevOps. DevOps, yeah. That's how things are. I didn't realize QA was in there too, so that was something.
We've taken it a step further. We actually don't have pager duty on the DevOps, but we have an application support team that has the pager duty, and they monitor the production level app. And DevOps we kind of formed it as being in between development and operations, and saying that we're automating whatever it is that can be automated. So the automation engineers.
Yeah, we took a more encompassing thing that's all there was as DevOps. So it was switching from development to application support, but it's also,
Yeah, just to build on that story a little bit, because going back to the early CI days where people were just discovering CI in general, if you're part of an organization that has multiple teams, you probably don't want to reinvent CI 50 different times. If you have 50 teams, so it seems like logical enough to have a core team that's going to kind of figure out the tooling, and create some kind of baseline infrastructure, you know, that hopefully is going to be, you know, applied across and leveraged across. But on the DevOps, maybe that is true at the framework level, but a lot of the responsibility is really, you know, kind of changing what you do as a developer, changing what you do as an
yeah, it definitely changes because you have to think about what happens after you throw your code over the
But
hedge.
how do you bootstrap it?
How do you bootstrap it? Yeah, so that's what the boss said. You give them pages. So the thing goes up in the night. Maybe they think about, and it goes up every night. At one point, they think maybe we need to change something in the application that the pager stops going off. So that's the brutal way of forcing that change.
It's also the pragmatic way, because if developers are 3 times removed from the application support team, they actually don't know the pain of the app support team. You know, one of our pains is logs. We have extremely verbose logs. We have Splunk to decipher those logs, and we have something like 165 errors per hour that are, well, they're not really errors, that's just the way the system behaves according to development. Now, find the real error in that feedback loop.
Yeah.
That's why you give the pager to the dev team. It's like, because they do the logs.
Exactly, yeah. So that's a pragmatic way, yeah.
I have a second that to your notion about the logs. One of the things that our team did at least was they put Sentry in place, and then basically the whole entire dev and QA team are completely on the Sentry list for every single error that goes on. Not as much as for production, but for QA dev and all the other environments, we're all like kind of responsible for at least making sure we're looking at those errors and helping kind of address them. So that brings visibility to kind of that stuff, which instead of saying, oh, well, you know, I don't know what's going on over there and that, you know, you see it in your email, and you say you didn't see it, and you're just saying you ignored it. So,
No, but yeah, the pager thing is one step. The other point is 5 whys, and you need to go dive down. Why do things happen? So you just scratch on the first why, then it doesn't help. So we went through those things. We peek all those things. So you're down again. Tell me more about it. And you have to start telling me more about it.
I thought one of the things kind of interesting is which at the beginning you have that box and you have the dev and the ops and the QA team in the same one, and then now once you have those together and the QA guys are like, hey, I want to be a developer.
Yeah.
They're kind of like already writing some automation, hopefully. But the interesting thing is, like, from my experience, my observation is that the QA guy actually, they will be doing on a rotating kind of like different sprint, like, oh, this particular sprint, the QA guy will go in and doing all the code, and that leaves the dev guy. So, okay, someone have to do the test, and I'll have like Java, like senior Java developer, they will be like writing some linear tests. But that will piss them off, actually. But what happened is that at the end of the...
You see my problems.
Yeah, well, and also not the problem is that the QA guy really is not experienced enough to write the code, and then the Java guy, after they finish writing and testing, the next sprint they will have to go back and fix everything.
Yeah, you can also be like one of so it's like we did DevOps. We did DevOps in a different process that we don't want to be on with QA, we only want developers. Because they know enough ops, which is good. They're better in automation than any QA guy you can hire, because they would be really good in developers. It's another thing. They just don't hire us because it's part of the game. Yeah.
One more question, and we'll wrap it up.
That's not the beginning of what a QA person is. I mean, running the scripts is just running tests against what you think might be wrong. Your QA guy is going to get through the whole scripts, and he's going to get real inventive. He's going to be monkeying with keyboard. He's going to come up with spontaneous invention ways to see if he can break the hell out of everything that you give me in brand new ways that nobody ever thought of. That's what it is.
Yeah, but we want that all to be automated too. Which is important.
You can't automate that.
Yeah, that's.
Well, in a certain aspect, it comes down to like return on investment. How much time do you have to spend to just find that one little niche thing, right?
And as I said, there are no QA guys anymore. They're all DevOps. So yeah.
Certainly end user.
At our shop, we're kind of leading an effort on a new
have those feedback loops, throw stuff over the hedge.
Right.
And as I said, people who come to my company say they want to do DevOps and never met dev. In for a big, it's not easy. It's a big transformation, and they still need a guy with its ground. So there's a model for that.
Okay, great. Thank you very much, Kieran.